Hi students, here is an answer key for the 9.1 practice test, or it might be called 9.2 in your class. And make sure you check carefully that you have all the bonds and the dots or unshared pairs that are shown here. And if you have them all right, you can just stop watching after you check. Otherwise, if you keep watching, I will go through them one by one and model how to do them. But again, if yours don't have the dots, you'll lose a point. So I'll just kind of grade these here. If I look at this first one, I see I have my SI in the middle and the H's and F's all the way around. So that's the atoms arranged correctly. And the bonds are shown correctly because it should be 4 single bonds in this case. H each has 1, F has 1, and the SI has 4, which is correct. And the unshared pairs, the only atom in this group that has unshared pairs is F. So both F's have 6 dots, which means 3 unshared pairs. If I look at the next, before I go on, if your F's are going up a different direction and your H's a different direction, it's okay as long as you have 2 H's and 2 F's and they have the dots on the F's. The next one too, if your double bond O is going out a different way, it's okay, but we need to make sure we have the carbon in the middle with 2 H's and a double bond O on it. If you have the H's and O all around the carbon, you'll get a point for arranged correctly. If you've got the double bond like you should have, and the H's only have single bonds, that's correct. And then O, in this group, O has 2 unshared pairs or 4 dots. The next one, again, if your N is on the other side and your H is on the right, that's okay as long as you have the carbon in the middle and the C and the N attached to it. That's the arrangement. And then the bonds, we need a triple bond with the N and only a single with the H, and that gives the carbon its 4. And then nitrogen always has an unshared pair. So keep watching if you want to see me do these one by one. All right, I encourage you to use the bond chart, especially if you're having trouble with this still. So here's a bond chart, and you should have one at home. Otherwise, they are in different worksheets that we've done. So here's the test again. So my first step always is to think about what atoms I have here and what valence electrons and bonds I have. So in my formula, I see Si H2 F2. So that means I'm going to have 1 Si atom and 2 H atoms and 2 F atoms. Then I like to think about how many valence electrons do each of those kinds of atoms have. So Si, H, and F. I'm going to look at the bond chart. So I don't see Si here, but I know that Si is in the same group as carbon. So it's going to have 4 valence electrons and 4 bonds. So I'm going to write that here, 4 and 4. Now hydrogen, I hope you're starting to remember, it's always 1 valence electron and 1 bond, 1, 1. And then F, I'll look back up here and we'll check the hydrogen too. You see hydrogen and the halogens are in this column because even though they have different numbers of valence electrons, H has 1 and the halogens have 7. The halogens are FClBrI. They're in group 17 on the periodic table. They all have 7. But what they have in common with H is they just want 1 bond. So I see H always looks like this with 1 bond and no dots. But the halogens will always look like F here with 1 bond and 6 dots to show their 7 valence electrons. So this is 7 valence electrons and 1 bond for the F. So they kind of go above, below together to know like what do I have and what do they need. So hopefully you're getting used to that notation. Now, the trick is, or one good tip is, put the one that needs the most bonds in the center. And then I'm going to put that into the middle of my space. So SI needs the most bonds. It has to go in the middle. Now remember, I actually have two H's to work with. They each only want one bond. So I'm going to start putting them on here. And then I have two F's to work with, and they each only have one bond. Want one bond. So when SI wants 4 and there's two H's and two F's, it makes sense for them to surround the SI. Now my last step is the unshared pairs. I see above and below the SI 4 and 4. That means all of SI's valence electrons are in a bond. Each bond has one of its electrons, so it doesn't have any left to itself that are unshared. Hydrogen is the same. One electron is in the bond. 1 and 1 above below means no extra valence electrons that are unshared. But now look at F. We have 7 electrons, 7 valence electrons, and only 1 is in the bond. So if I subtract, I know I have 6 extra electrons. If I'm an F, I have 6 extra electrons that are not shared in the bond. So just like with our dot diagram for F, when we learned how to do those, it would have had 7 dots. Now we still have the 6 dots showing the unshared, and then the 7th is in the bond connecting it to SI. So you see how the one I just did, I ended up with them in a little bit different arrangement from up here. The F and the H's aren't going out the same way, but that's okay because it's just like we're looking at it from a different side is all. So that is that one. Let's try the next one. One C atom, one O atom, and 2 H's is what I have to work with. I'm going to go up to my bond chart, and I know I'm starting to memorize this, that C is 4 and 4. We see carbon a lot. So C has 4 valence electrons and 4 bonds. And the H is 1 and 1. I'm remembering that. That seems to come up a lot. And then the O is here in group 16. I guess I'll pick a different color. And so it has 6 valence electrons, and that means 8 minus 6, it needs 2 bonds. Okay, so I'm going to put above, below those numbers. Carbon was 4 valence electrons, and that means 4 bonds are needed. Oxygen was the 6 and the 2, and hydrogen is always 1, 1. Now remember, who needs the most bonds? That's the one that has to go in the middle. The one I'm starring means, that one needs a lot of bonds. I'm going to put it in the middle. So carbon in the middle. And now I have 1 O to put on there and 2 H's. So I'm going to start just any way, it doesn't really matter. A single bond first. Everyone has a single bond. Now I want to think about, do I have the bonds that I need? And I look, and carbon says it needs 4 bonds, but on this carbon count, 1, 2, 3, it only has 3. Oxygen needs 2 bonds, and I look and it only has 1 there with the carbon. So since the oxygen and the carbon both need another bond, then that's where I'm going to put my double bond. They both get a double bond there. They both get an extra bond by sharing more. Now I think about the unshared electrons. Do any of these atoms have unshared electrons that I need to show as dots? Again, the way I do that is I look above and below on our numbers here to the left. So carbon has a 4, 4. That means 4 electrons, but they're all in a bond because each bond uses 1. Oxygen, though, has 6 and 2. So that means there's 4 left around oxygen. 1, 2, 3, 4. Hydrogen, 1, 1. Nope, no dots there. Now, I just did that kind of in a mathy way, just some simple subtraction. But remember, you can also use your bond chart. So let's go look at these atoms on the bond chart. See how oxygen has 4 dots around it in a double bond, and the carbon and the hydrogen don't have any dots? If I look at my bond chart, I should see ones like that. If I'm right, I should see it here. And oh, there's the oxygen with 4 dots and a double bond. There's a hydrogen with no dots and a single bond. And here's a carbon with 2 singles and a double and no dots. So using the bond chart will help you if you're more of a visual person. Last one. So this time I have an N, a C, and a H. One of each. So I'm going to use the bond chart to find my valence electrons and bonds. Let's look at N. 5 valence electrons and 3 bonds. And there was a C, I've seen that one a lot, 4 and 4. And an H, I've seen that one a lot, they're 1 and 1. So for nitrogen, 5 valence electrons of its own. That means it has to make 3 bonds to get to 8. Carbon has 4, which means it needs 4 bonds to get to 8. And hydrogen only has 1, but it's the exception. It only needs 1 bond to get a full first energy level with 2. Now again, who needs the most bonds? Put that one in the middle. Carbon. Now the nitrogen needs quite a lot of bonds, but the carbon needs more. So I'm going to start with a single bond. I'll do this one to the left this time. Up above, I think I did it to the right, just to show you it doesn't really matter. Start with single bonds. Now ask yourself, who needs more bonds? There's no more atoms here, 1 N, 1 C, 1 H. So I can't bond any more to any more things. I have to make it work with just these. So when I see that nitrogen needs 3 bonds and it only has 1, and carbon needs 4 bonds and it only has 1, 2, then I know that the nitrogen and the carbon both need 2 more bonds. So that's going to have to be where there's either a double or a triple. I'll start with 1 more, that's a double. They still don't have enough. We see nitrogen with just 2 and carbon now with 3 lines touching it. So they still both need 1 more, so I'm going to put a third. If you're visual, you should see that up here, that carbon, if it only has 2 things to bond to, it has to have a triple and a single, or it could have 2 doubles. But since hydrogen only always has a single, that means that this would be the hydrogen, and then over here is our nitrogen with 3. So the visuals help some of us more. Okay. So I do have one more thing to add. The bonds are correct, but now the dots. Again, if the numbers above and below here match, then there's no dots. But I see with nitrogen, 5 and 3, simple subtraction, that means there's 2 electrons that are unshared. 3 are in the bonds for the nitrogen, and 2 are left unshared. Carbon, 4 and 4, there's no unshared. Hydrogen, 1 and 1, no unshared. So these patterns continue. You see, in all of our examples, hydrogen does not have dots, neither does carbon. All right. I hope this helps. Good luck studying. Email your teacher if you need anything.